Hello and welcome to today's video, 615 Maximal Network Rank. So there's n cities with some number of roads connecting them, and each road indicates that there's a bidirectional road between them. Okay. Okay, so the network rank of two different cities is the total number of directly connected roads to either city. And if a road is directly connected to both cities, it's only counted once. We want to turn the maximum network rank of the entire infrastructure. Okay, so given n equals 4, and then these are the roads that we have. Our output is 4 because the network rank of cities 0 to 1 and 1 to 4. Oh, no, wait, sorry. The network rank of cities 0 and 1 is 4. And because there's 4 roads connected. Okay. Same thing with this one. 5 roads connected to cities 1 and 2. Okay, that makes sense. So let's come up with a plan to solve this. An idea I have is to first traverse through and determine what the count is of every single road. Basically, for every single city, we want to see which cities are connected to what roads. So we need to figure out a way to do that. The next thing we need to do is we need to figure out, given let's say like the city like 0, for example, we know it's connected to this road and we know it's connected to this road. So let's say it's connected to 2 roads, right? We have 1, it's connected to 1, 2, 3, and 4. So this is connected to a total of 4, right? 1, 2, 3, 4. But the problem is there's 2 overlapping ones. So if there's an overlapping one, then we want to not count that as part of our count, because let's say like an idea which I'm thinking of is you basically connect the cities to the roads, or like count which cities have which roads, and then given this, then we can figure out how many what their maximal network rank is by counting all of the roads they have and subtracting the ones they have in common. So yeah, well, the most they would have in common is going to be just 0 and 1, like the road between 0 and 1, because those ones are going to have both of them. So we have to account for that. So I guess what we can do is determine, or give a network rank by adding roads in city 1 plus roads in city 2 subtracted by common if exists. So at the very end, we can basically have an accumulator which checks for that, and then we can turn that as our final result. So yeah, seems like a good game plan. I'll begin coding this up now, just see how it goes. So for every single city, for city in range length of n, because that's the number of cities there are, we want to first count which cities belong in which roads. So we'll do we'll have a hash map, let's say here, and then we count this. Or let's actually, to make it better, let's call this count. We'll have a count hash map, and then we'll add it to the city if you're given if it's in the road, if it's in the city, right? So, or sorry, like if the city is in the road, which is like this, right? So we want to do, actually, before we do that, I think we need to create a default dict instead. So this way, it'll be initialized with a default value of 0 once it's, yeah. If it doesn't already exist, if you call this and you do default dict, it'll have a default value of 0, so we won't have to initialize it. So we're gonna add the city 0, or we want to add the city 0 to here, plus equals 1, and then count city 1 plus equals to 1. Now that we have the count, it should have the count of every single city. What we can do is we can have the max network rank, and then we can have that equal to 0, and then for every single road again, or yeah. So so next thing we need to do is we need to add the roads in city 1 plus the roads in city 2, and then common if it exists. So for city in count, for city 2 in count, for this one, so for every single city in for city 2, what we want to do is we first want to check to see whether or not there's a common one. So if there's a common city that exists with in between them. So what we need to do is we need to check. So for if we need to add the roads in city 1 and city 2. So max network rank is equal to the max of city 1, or sorry, the max of max network rank, and then city 1 plus city 2 plus common. But we're not sure what that will be yet. Like whether or not we should add it, because we don't know if it's in common yet. So we can do cur rank. Let's set like up a current rank variable, which is equal to city plus city 2, and then we want to do if city in common, like we need to figure out something to replace this with, but for now we can do that. If city is in common, then we want to do cur rank plus equal the value, or actually we want it to be minus equals 1, because we don't want to count the common value. And then at the very end, what we can go ahead and do is return this one and the current rank. Now, so we actually need to check to see whether or not the two cities are common, and in order to do that, let's think about how to do this. We can effectively traverse through the roads and then check to see whether or not it exists first, right? To check to check if cur rank is in city. Okay, at the very end we want to just return max network rank. So to check if it's a common city, what we can do is we can first create a tuple of the roads. So roads is roads, or a set. Yeah, we can do a road set of them. So what I'm thinking of doing is, well, for the city in city 2, what we need to do is we need to loop through all of the different roads in order to determine whether or not they have 2 in common, right? But in order to do so, we have to go through for every single city pair, right? For all of this, we actually have to go ahead and check every single one again. And that's inefficient because we don't want to be looping through every single road every single time. That'll be another layer. That'll be like an O of N operation, so it'll end up making things inefficient. So what I'm thinking of doing instead is having a roads set, basically a set version of the roads, containing tuples of the cities instead, to make it an O of 1 operation to check whether or not it exists. Because, it'll be an O of 1 operation to access it instead. So I'll go ahead and code it up to see what, to let you guys know what I'm talking about. We'll have a road set here, and then we'll have a set of tuples think this is the syntax, tuple of road for road in roads. Yeah, so we have tuple of road for road in roads. For every single road, we're going to create a tuple of this, and we're going to put this inside a set. And then from here, what we can do is we can do if city, city 1 or city 2 in roads set, or city 2 city in roads set, then we're gonna subtract the current rank by 1. Otherwise, we're gonna keep searching for the maximum network rank. Yeah, so this should be good. Let me go ahead and check for any syntax errors. Tuple road for road and roads. Yeah. Oh, yeah. You can't be adding city 1 and city 2. Current rank should be the count of the city 1 and city 2. Yeah. Any other mistakes? I think it should be good, so we'll go ahead and run this now. Oh, right. Too used to writing len. Because it's an actual integer value. Int type is not subscriptable. Oh. For the count of city 0. Well, it should be city 0. Because... Oh. It's not city 0. It's roads 0. So it actually has to be this. Where we have roads... roads for... Or, sorry. Oh, wait, no. So for the counts... So for every single city... We want the count of... Oh, okay, actually, yeah. So instead of this, we want for road in roads. We want the counts for every single road in the roads. We want the counts of roads 0, 0 to be added by 1. And then the count of roads 0, 1. Or road 0, 1 to be added by 1. So, yeah. Because we're adding the road. The very first option is part of the count. And we're adding this one as part of the count as well. Oh. List indices must be integers or slices, not a list. Let's have a look here. Oh, right. Yeah. Thought it was an index. Okay, let's have a look. This output is 6 when you should be expected to have 4. Let's have a look at what's missing. For every single road in roads, this one adds 1, this one plus equals 1. Oh, this should be from the range from city to N. It should be, because you only want to try the cities which are ahead of them, because the other ones will already have been accounted for. Or, huh. Let's see. Hmm. Six, 5. Six is 4, 6 is 5, 6 is 5. So 1, 2, 3, 4, 5. Oh, I see. Wait, no. It should be the city itself, and then we wanna add this. It's a tuple of the road for road and roads, right? Hmm. Let's have a look here and see. Subtracted by 1 for every single one of those. And 1 into the maximal network rank. I think what you have to do is actually do city plus 1, because you actually don't want to include this current city as you're doing this, and it's inclusive. So we can try that. Okay, yeah, that should be it. Okay, nice. So if we go ahead and run and submit. Okay, nice. Pretty good. Time complexity of this one. You're first looping through for every single road in the roads. So this is O of N, where N is number of roads. And then for this one, you're looping through the number of cities twice, right? So let's go M, 2M, or M squared, because that's, you're looping through every single city twice. You're checking all the different combination pairs. The actual act of creating the set is going to be another O of N operation. So the final time complexity for this one will be O of N plus M squared. So that's going to be our time complexity. And then our space complexity is going to be O of N, because you're storing the number of roads in the tuple over here. And then, yep, apart from that, that should be it. Thank you guys for watching.